Now, sequence and series, there are two words that they use them almost together. That is, when you say sequence, a sequence is a function whose domain is a set of consecutive number or integer, usually begin with 1. That is, you can be given a what? A function, and that function will define a sequence. That is, if I give you a function, let's say I give a function 2n or 2k or 2x, where your n is the domain. Then if I ask you to generate the sequences, then you are going to start from when n is equals to 1. And those values you will get at a particular point is what is called sequence. Are you with me? Now, we have two types of sequence. We have what is called infinite sequence, and we also have the second one, which is called finite sequence. When you say infinite sequence is a sequence where you don't know your end point. You don't know your end points. You know you are starting from 1 because one integer, positive integer start from 1, or natural numbers start from 1, but you don't know where you are going to. And that type of sequence is what is known as what? Infinite sequence. That is why after a particular term of the sequence, they will use dot, 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 telling you it continue. That is infinite sequence. But the second one is what is called finite sequence. When you say finite sequence, then the sequence will tell you when you are going. The sequence will tell you where to stop. Whenever you are given a sequence and they tell you where to stop, that sequence is what? Is finite. That is, you can count the number of sequence. Let's assume I give a function. Let's say I said 2k plus 1, and I ask you to generate the first 5 terms of the sequence. It means you are going to start from 1 and end in 5. That is what is a finite sequence. That is, you know where you are starting from and you know where you are going to stop. But infinite sequence, you will know where you are starting from, but you don't know where you are going to. Do you understand now?
Yes.
Do you understand me?
Yes, sir.
Class, you get the
Yes,
difference
sir.
between finite and infinite sequence, Abi? Okay,
Yes.
let's look at the example. Look at this sequence. Write down the first system of the sequence. Is it a finite sequence or an infinite sequence that this sequence is going to give us? Is it a finite sequence or infinite sequence that is going to give us?
Finite.
It's going to give us finite sequence because we already know where we are going. We want to get the first 6 terms of the sequence, Abi. That is,
Yes.
the first sequence, the second sequence, the third sequence, the fourth sequence to the 6th sequence. Now, the domain of this sequence will be from 1 to 6. Now, when n is equals to 1, what are we going to have? We are going to have what? When n is equals to 1, what's the sequence going to give us? Is 0. Do you see that it's going to give us 0? Class, when n is equals to 1, the sequence is going to give us 0. Do you see it?
Yes, sir.
That is 1 minus 1 divided by 1. 1 minus 1 is 0. Divided by 1 is going to give me 0. The second sequence, A2. A2 is going to give me what? 1 over 2. That is 2 minus 1 divided by 2. Are you with me? Are you getting it?
Yes, sir.
Are you getting it?
Yes, sir.
What's going to be A3? What's going to be A3? The third sequence.
1.
The third sequence. What's going to be A3?
Yes, sir. Yes.
You're saying yes. I'm asking you a question. What is going to be A3?
2 over 3.
2 over 3. Thank you. What's going to be A4?
But
2
A4.
over 3.
3 over 4.
A4,
Three
A4,
over-
A4, A4.
3 over 4.
Thank you. And so on. Now let's see. Your A1 will be 0. Your A2 will be 1 over 2.
2 over 3.
Your A3 will be 2 over 3. Your A4 will be 3 over 4. Your A5 will be 4 over 5. And your A6 will be what? 5 over 6. Those are the sequence. We have this type of sequence is called finite sequence. And the sequence are 0, 1 over 2, 2 over 3, 3 over 4, 4 over 5, and 5 over 6. Do you understand? Now, let's look at this now. Look at example 2. Find the first 4 term and the 23rd term of the sequence. Whose the general term is given as? We want to get the what? The first 4 term. Is that not?
Yes.
And 23rd term of the sequence. Now, what's the first term of this sequence? What is going to be my A1? What's going to be my A1?
1.
What's going to be my A1?
4.
I didn't get. What's A1?
4.
It's not 1. Look at it very well. A1 is not 1. Look at it very well.
Minus 0. 0.
No. A1 is minus 1. Is minus 1. Look at it. When n is equals to 1, minus 1 raised to power of 1 will give me minus 1. And 1 square is also 1. 1 times minus 1 will give me minus 1. Do you understand it?
Yes, sir. Yes, sir.
That is A1. What's going to be A2? What's going to be A2? What's going to be A2?
Minus 4.
Look at it very well. Don't just jump. It's not minus 4.
Minus
Look at
4.
it again. It's not minus 4. It's 4.
4.
It's 4. What is minus 1 raised to power 2 is 1. 2 raised to power 2 is 4. 4 times 1 is 4. It's not minus 4. What is A3?
9.
What is A3? A3 is not 9.
9.
You guys are not getting it right. A3 is not 9. You are only considering n squared. You are not considering minus 1 raised to power n.
Minus 9.
You will consider minus 9.
Minus 9.
Is minus 9. Let me just tell you. Minus 9. Yes, it's minus 9. It's not 9. You will consider both n squared and minus 1 raised to power n. Whenever you are squaring negative number, if you are squaring it with even, you are going to have positive. But if you are squaring with odd number, you are going to what? You are going to have negative. You understand? Now, what is A4? What is A4?
Sir, I don't understand.
You don't understand?
16. Yes. Do that.
What is A4?
16.
A4 is 16. Okay. If you don't understand, signify. If you don't understand, let me see your hand that you don't understand. Do you understand? Okay. Amina. Okay. Thank you. Amina.
Sir.
Now, favor. Now, let me explain it again. I said, listen and get it right. This question, do you understand the first one? Example 1. Do you understand example 1?
Yes, sir. Yes, sir.
For those of us that raise our hand, do you understand example 1?
Yes, sir.
Okay. I said example 2. If you look at example 2, the general term given to us comprised of 2 sides. we have minus 1 raised to power n and n square. Whenever you are considering your n, you must both consider the two. Minus 1 raised to power n times n square. That is what you are going to consider. Now, I want to get my A1. A1 means n is equals to 1. When n is equals to 1, if I put it inside the general term, I'm going to have minus 1 raised to power 1 times 1 raised to power 2. Do you see it? Now, minus 1 raised to power 1 will give me minus 1. Times 1 raised to power 2 will give me 1. 1 times 1 will give me 1 times minus 1 will give me minus 1. Do you understand that one?
Yes.
Do you understand?
Yes,
Amina Junaid.
yes. I'm not Jimo.
Favor, do you understand it now?
Yes, sir.
Okay. Toiba, do you understand? Toiba is not here with us.
True.
Okay.
Yes,
Now,
sir.
favor, what is now, when n is equals to 2, favor, let's look at it together. When n is equals to 2, we are going to have minus 1 raised to power 2 times 2 raised to power 2. Minus 1 raised to power 2. Whenever you are squaring negative, whenever you want to raise negative value, listen, whenever you are raising negative value, if that's something, what you are using to raise it is positive, your result will be positive. But if what you are using to raise it is odd number, sorry, I say positive, even number, your result will be positive. But if it is odd number, your result will be what? Negative. Let me repeat myself. Whenever you are raising negative number, now if what you are using to raise it is even, your result will be positive. But if it is odd number, your result will be what? Negative. Now, what is A2? A2 is going to give you minus 1 raised to power 2 times 2 raised to power 2. Since minus 1 raised to power 2, that 2 is an even, then it's going to give me 1. 2 raised to power 2 is 4. 4 times 1 will give me what? 4. That is A2. Now, Amina, what is A3? Amina, what is A3?
Sir, please, I want to ask you one question. Is it if it is even number, it's going to give you that number back? The number inside the bracket back, Abi?
Yes, thank you. Listen. When you are raising minus 1, when you are raising minus 1, let me just say this. When you are raising 1, any power of 1 that you raise, you are going to get 1 back now. You know that, Abi? Do you know that 1 raised to power 1 million is 1? Do you know that?
Yeah.
Do you know
Okay,
that?
yes.
Okay, thank you. Now, but when you are raising minus 1, it depends on the power that you are using to raise it. If that power is even power, then you are going to get 1. But if the power is an odd power, then you are going to get the minus 1. Do you understand now?
Yes, sir.
Now, don't forget you
Yes.
have n square. Anything you get, either 1 or minus 1, you use it to multiply n square.
Okay.
Now, what is now A3? A3.
Nine.
Minus 9. Thank you. You all see that is minus 9 now.
Yes, sir.
Because minus 1 raised to power 3 will give me minus 1. And 3 raised to power 2 will give me 9. Then 9 times minus 1 will give me minus 9. What is now A4?
16.
Eh?
16.
16. Thank you. That is the first 4 time. Now, and they also ask us to find the what? The 23rd term. Now, what is the 23rd term? 23rd term. What is the 23rd term? Who can tell me? You said, what is 23rd term?
529.
You are wrong. You are
Minus
wrong.
59.
Yes, minus 529 minus
minus
why?
529.
Thank you. Minus 529 because minus 1 raised to power 23 will give me minus 1 because 23 is an odd number times 23 raised to power 2 will give me 529. 529 times minus 1 will give me minus 529. Do you now understand it? And that is how to generate sequence. That is how to generate sequence from given function. Now, let's look at my own solution. Look at the solution now. A1 minus 1, A24, A3 minus 9, A4 16, and 23 raised to minus 529. Now, let's move on. Now, the first one we look at is given the general term, we generate the sequence. What if you are given sequence and they ask you to generate the general term? Look at it. The two examples we look at is you are given what? A general term, you generate the sequence. For now, we want to look at what if you are given a sequence and they ask you to generate general term. Are you with me?
Yes, sir.
Okay, thank you. Now let's look at the example. Look at this example, this 3 example. We are given this sequence. Find a positive general term for the following sequence. The first sequence we have 6, 12, 18, 24, 30. Now who can tell me what will be the general term of this sequence? What's going to be the general term of the sequence? For the first one.
N is equal
What's going to be the general term of this sequence?
N is equal to N times. N is equal
Now let me tell you, I've told you the domain of a sequence must be what? Must be an integer. Now if you look at this sequence I have, that first sequence 6, 12, 18, 24, 30. There is something that is common to them. What is common?
6.
plus
6 is common. Then if I remove 6, then what am I going to have? If I factorize out 6, I'm going to have 1, 3, 4, 5. Can you see it?
2, 3, 4, 1. Yeah.
Abi? Then it means if I want to continue the sequence, I will see that the next one will be what? 36. Abi?
Yeah.
The next one will be what? 42, and so on. Then the general time of that sequence will just be what? 6n. Do you see it?
yes, sir.
Do you see that the general time will be 6n? Since the first time is 6, then I can write that first time as 6 times 1. The second time is 12. I can write it as well 6 times 2. The third term is what? 18. I can write it as 6 times 3. Then if I ask you to find the 100th term, it's going to be what? 6 times 100. Abi?
Yes, sir.
It means your number of
Yes, sir.
term is just n. And it's going to give me 6n. Do you understand it now?
Yes, sir.
That is how to generate sequence and how to generate general term from given sequence. Now the second one, who can tell me what is the general term for the second one?
10n.
N
No,
N is equal to
10n.
it cannot be 10n. If you are saying 10n, listen. Oh, if you are saying 10n, the first one 10 times n. Okay, is 10n correct? No. Do you see that 10n is not correct? If I say 10n, what it means is that the first term will be 10, the second term will be 20, the third term will be 30. Is that not?
No.
n.
Eh?
10 raised to power n.
Thank you. God bless you. 10 raised to power n. That is, you can't say 10n because if you say 10n, you are telling me the first time is 10, the second time is 20, the third time is 30. But it is 10 raised to power n because my first time is what? 10. The second time will be what? 10 square. The third time will be what? 10 cube. The fourth time will be what? 10 raised to power 4 and so on. Do you understand?
Yes, sir.
You see, the first term is 10 raised to power 1, the second term is 10 raised to power 2, the third term is 10 raised to power 3. If I tell you what is the 100th term, it's going to be what? 10 raised to power 100 and so on. Now, what about the third term? The third question, number 3. What's the general term for number 3?
1 over 2n.
1 over 2n. 1 over 2n. Is that correct? 1 over 2n. Is that correct?
1 over 2 plus n.
1 over
2 plus n.
2 plus n. Is that correct? Now, let's see. If you say 1 over 2 plus n, 1 over 2 plus n is not correct. So look at it very well. Because your second term will fail. Your second term is going to fail. If you say 2 plus n, the second time will just be 2 plus 2, which is 4, and I have 5. It's not correct.
An is equals to
Okay.
minus 2 over 5n
Minus 2
over 15,
Ah.
sorry, over 15.
What are you saying? What are you saying? Look at it very well. The first thing you need to take note, which I appreciate some people that answered, is that it's going to be 1 over because everything is 1 over. Your AM must be 1 over something because everything is 1 over. Now, look at the series at the denominator now. What is the series?
2.
1 over what? I'm waiting. 1 over what?
1 over 2n minus 1. 1 over 2 plus n minus 1.
If you say 2n minus 1, are you sure you are not correct? Because when n is equals to 1, I'm going to have 2n, which is 2 times 2. 2 times 1 is 2 minus 1 will give me 1. It's not correct. Look at it again. You are getting closer. You are getting closer. The first one is 3 now.
1 over 2n plus 1.
Thank you. 1 over 2n plus 1. 1 over 2n plus 1. Let's see. When n is equals to 1, I'm going to have 1 over 2 times 1 plus 1. It's going to give me 1 over 3. When n is equals to 2, I'm going to have 1 divided by 2 times 2 is 4 plus 1, 5. Do you understand it now? Look at the answer. The answer is 1 over 2n plus 1. Do you understand? Favor, do you understand?
Yes, sir.
Amina, do you understand? Amina, do you understand? Amina,
Sir?
do you understand it?
No, sir.
The last one, I don't get.
Okay, let me explain it again. I said, but you understand the first two. Do you understand the first two?
Yes.
Okay. Now, this second one, whenever you have a fraction and you want to get the general term, look at what you have on the top at your numerator. You will see that is 1, 1, 1, 1. Everything is carrying 1. then it means that 1 will be there. Now, the only thing that is changing is your denominator. The first number in your denominator is 3, Abi.
Yes, sir.
The second number in your denominator is 5. The third number
Yes.
is 7. The fourth number is 9. If you look at that trend, you say when n is equals to 1, you have 3. How is it possible for you to have 3 when n is equals to 1? Is that it means 2 plus 3 is going to give me 1. Abi, 2 plus 1 is going to give me 3, Abi.
Yes, sir.
Yeah, and I know that my n is 1. Just put that your n. 2 times 1 will give me 3. 2 plus 1 is going to give me 3. Look at the second one. I have 5. And I know that 2 plus 1 cannot give me 5. But I know if I multiply 2 times 2 plus 1 is going to give me 5. Do you see it?
Yes, sir. Yes.
The third one is 7. I know that I cannot get 7 if I add 2 plus 1. But if I say 2 times 3, and it's the third, it falls in the third term. 2 times 3 will give me 6, plus 1 is going to give me 7, and so on. Do you now understand it?
Yes, sir.
Miriam or Dusin, what's the problem? Just speak out. Miriam. Miriam, do you understand? Miriam or Dusin?
Yes, sir.
Okay. Now let's move on. We want to look at what is called or recursion formula. This recursive or recursion formula is just a combination of, sometimes you will be given a particular term and the general term, and they will ask you to get another term. Let's assume I give you a first term and I give you a general term together, and that our general term is in form of that recursive. Then what am I going to have? And that is what we want to look at now. Do you understand me? Now, do you get me? Do you understand? Class, you guys are not responding.
Yes, sir.
I said when you are talking about recursive, you are going to be given a particular term and the general term. You are going to be given a what? A particular sequence. Let's say you are given A1 and you are given a general term that is involved of what? A1. Then you need to know the other term before you can get the term. Let's look at the example. Look at this example. Can you see my screen?
Yes, sir.
Yes, sir.
Okay. The question says, find the first 4 terms of each of the following recursive sequence defined by, look at the first question. We know our A1, our first term, Abi, and we also know our next term or the other term, we call it A1 plus AK plus 1. I use K instead of N. You can use N if you like, but here I use K. Do you understand? And the question is asking us to get the first 4 terms. The first 4 terms. You know your first term. We want to get our second term. But there's no how you will get your second term without your first term. There's no how you will get your third term without your second term. And there's no how you will get your fourth term without your what? Your third term. I don't know if you understand me.
Understood.
Do you understand me?
Yes, sir.
Okay, what's my second term now? What's the second term going to be? Look at it yourself. What's the second term? Who can tell me what's the second term? My second term is going to be when K is equals to 1. If K is equals to 1, my general term will just be A2 equals 2A1 plus 3. And I know my A1 to be 5. Now what?
Stop! Sorry. Ó yẹ kí wọ́n rán létí pẹ̀lú orí ẹ̀ tó dàbí ètò ìgbọ́ tó máa rán létí bọ́ tó máa fi kára.
They are fighting. They're not saying really abuse. Is the class over already? Is the class already over?
No.
Sorry, is my network? Mubarak Tijani, please make me to be the host. Mubarak Tijani, make me to be the host. You are now the host. Make me to be the host. Mubarak Tijani. Okay, thank you very much.
No.
Okay, sorry, is my network. I said we are talking about recursive formula. I said you want to get the first 4 times of each of this question. The first one, we know our A1. Our A1 is given to be 5. And we are also given some other, the general term that define the other sequence. That is, AK plus 1 is equals to 2AK plus 3. Now, for me to get the other sequence, I'm going to give K numbers, Abi. Now, for me to get my A2, what's going to be A2? A2 will be when K is equals to 1. Do you see it? Class, do you see it? If my K is equals to 1, do you see that I'm going to have A2 equals 2A1 plus 3? Do you see it?
Yes, sir.
Now,
Yes.
what's that going to be my A2? What's going to be A2? What's going to
13.
13. Thank you. A2 is 13. Thank you very much. It means you understand. What's going to be A3? What's going to be A3? A3 will be when K is equals to 2.
Okay. It's just 2. I'm coming. Okay.
It's only one person that is doing it. Others, what are you doing? What is A3? Your A2, you cannot get A3 without knowing A2. And you said your A2 is 13. What's going to be A3?
39.
Is what?
39.
39K.
Maybe our A2 is 13.
It's 29 now. 26 plus 3 is 29. What's going to be A4? A4 encore.
So, 48 plus 3.
119.
So 51.
Eh?
51.
You sure?
18.
It's not
51.
51. Check it.
61.
It can't be
The way
51 now.
29.
29 times
That
2.
was the question.
I said, what is A4? A4 is 61, 61, 61. 29 times 2 is what? 58 plus 3, 61. Do you understand? Now,
Yes.
I
look
don't
at the
understand.
second
Sir,
question.
please set this recursion formula all over.
So
You
I can't
said
get the first one.
you can't get the
I didn't get
formula.
it. I didn't
I don't
understand this
understand the
recursion
first one.
formula.
I'm telling you now, listen. Get it clear.
Sir, please explain the recursion formula again.
I want to do that now. Listen. Are you with me?
Yes.
Okay. I said
Sir,
recursion
please, I don't really
formula.
understand the recursion formula.
And listen, I want to explain. Everybody should listen and listen. I said recursion formula is that you are going to be given a particular sequence or a particular term together with general term that define other terms. Do you understand? You know, in our previous studies, we have studied how to generate sequence, and we have studied how to also generate general term. Now, recursive formula combine the two. You will be given a particular term or sequence, and you will also be given the general term. They will now ask you to find some other sequence. Do you understand me? Now, if you look at the question 1, you are given the first term of a sequence to be 5. And we are now given a general term that defines the other sequences. That is why we are given AK plus 1 equals 2AK plus 3. Now, the other term that we are going to be given will be a function of the what? A sequence. That is, there's no how you want to know a particular sequence. You must know the sequence before it. Are you there with me? If I want to know the 9th term of a sequence, I need to know the 8th term of the last sequence before knowing the 9th. That is what is called recursive sequence. Now, the example 1 given to us, we are given A1 to be 5. We want to get A2, we want to get A3, and also we want to get A4. Are you with me? Are
Yes,
you with
sir.
me? Now, A1 is 5. Now, I want to get A2. My A2, how can I get A2 from that general term? Is where K is equals to 1. If K is equals to 1, then I have A2. Do you see it? And we have A2 equals 2A1 plus 3. And my A1 is known. What is A1? 5. If I put that A1 into the A2, I'm going to have A2 equals 2 times 5 plus 3, which is 13. Do you understand that one now?
Yes, sir.
Do you understand it now?
Yes, sir.
No,
Now, the same thing
Yes,
to
sir.
A3. A3 is going to be what? A3 equals 2A2 plus 3. And A2 is 13. I'm going to have 2 times 13, which is 26 plus 3. It's going to
your
give me
class is over.
29.
You cannot ask them missions to.
And so on. Do you understand now?
Oh, Dios.
Can we move to question 2? Oh yeah, do question 2 as classwork. Oh yeah, question 2 classwork. Everybody do question 2 as classwork. We are given A1 to be 4, A2 to be 3. Then we are also given general term, which is what? A K plus 2 equals 3K plus 1 minus 2AK. Oh yeah, do it. Help me to find A3 and A4. Help me to find A3 and A4.
A3 is minus 5 and A4 is 5.
A3 is minus.
I'm coming. Oh. This is the first answer that we did. You said A3 is what?
-5.
-5. Okay. A4 ńkọ́?
5.
A4 is 5. Any different answer? Any contrary answer to that?
My A3, I got -3.
And your A4 ńkọ́? Your A4 ńkọ́?
I'm solving it.
Okay. Others should also try it. There's no how you will understand if you don't try it.
My A3 is -2. A4 is -3.
Okay. I'm getting people with different answers. I like that.
Sir, my A3 is -2 and my A4 is 8.
A4 is what?
8.
My A4 is -4 and my A4 is.
Okay, now let's listen. We want to try it together now. We want to try it together. Now I have my A1, A2. I need to get A3. Now for me to get A3, what am I going to do? I will say let K equals to 1. Is that not? Talk now.
Yes.
Now if K is equals to 1, I have A3 equals A2 minus 2A1. Do you see it? A3 equals A2 minus 2A1. Now, A2 is 3. I have 3 minus 2A1 will be 2 times 4, which is 8. 3 minus 8 will give me -5. My A3 is -5. Do you see it? If you don't get -5 as your A3, you are wrong. Do you see that is -5 now?
Yes, sir.
So please explain it again.
Okay, thank you. I said I want to get A3 and A4. Now I know A1 and I know A2. If I want to get my A3, I will say let K be equals to 1. Then if I put 1, I have 1 plus 2 will give me A3. Now A3 equals 1 plus 2. AK plus 1 will give me A2 minus 2A1. Do you get that? A3 will be equals to A2 minus 2A1. Do you understand that one? Do you get that one? A3 equals A2 minus 2A1. I'm asking you.
Yes, I understand.
Okay, thank you. What is my A2? A2 in the question is 3. Is that not?
Yes.
Minus 2 times A1. What is A1? 4. 2 times 4 will give me 8. Then we have 3 minus 8, which is -5. Do you understand now?
Yes, sir.
Okay. What is now A4?
Yes,
A4
sir.
means when K is equals to what? 2. And A4 will give me what? A4 equals A3 minus 2A2. A3 and A4 equals A3 minus 2A2. What is A3? -5 minus 2 times A2, which is what? 6. -5 minus 6 will give me what? -11. The A4 is what? -11. Let's look at the answer. Do you see the answer there? Do you see the answer?
Yes, sir.
Yes, sir.
Do you now understand it?
Yes, sir.
It means they can ask you to generate a sequence by giving some text of that sequence, and that is what is called recursive sequence. If I ask you to generate A10 from this sequence, you cannot generate A10 without knowing your what? A9. And you cannot generate A9 without knowing your what? A8. You cannot generate A8 without knowing your what? Your A7 and so on. That is what is called recursive. You need to know a particular term before the next term. And that is that. Now, I want to look at another thing before time. We have Now, what we want to look at is summation notation. What we want to look at now is summation. The difference between sequence and series. Let me just tell you. The difference between sequence and series is that series is just the summation, the addition of the sequence. When you already generate your sequence, addition of all the sequence is what is called series. Do you understand? Now, addition of sequence is what is called series. Now, summation. This sign that you see is what is called the Greek sign you see, which is called sigma, is what is used as what? Summation. Is what is known as what? Summation. Can you see the sigma? Can you see the symbol?
Yes,
Can you
sir.
see the symbol? I want our response now.
Yes, sir.
That symbol you see is what is called
Yes,
summation.
sir.
Now, if you look at the last line, the last line. Okay, for example, the sum of these first
Get
5
me
terms
on
of
the
the
slides, please,
sequence.
please, please.
The sum of these first 5 of the sequence. Look at the sequence. 5, 7, 9, 11, 13. If I ask you to find the sum, what you are going to do is what? You are going to add 5 plus 7 plus 9 plus 11 plus 13. Is that not?
Yes, sir.
It's also the same thing of saying you've just find the word, the summation of the nth term, and you are going to define when the term starts from. Look at the sequence now. I said find the sum of, I use sigma to denote the sum, and I said you should start from what? The general term of this sequence is 2n plus 3. Now, I find the word, the sum of the first 5 terms of this sequence. The sequence, the general term of the sequence is 2n plus 3, and I'm finding the what? The sum of the first 5 times. That is why I start from n is equals to 1 to 5. Do you see it?
Yes, sir.
That is what is called summation notation. Let's look at an example. If I ask you to evaluate each of the following, summation of 4k, k from 1 to 6, what does it mean? If I ask you to generate this sequence, now generate this sequence, 4k, generate the first 4, 6 sequence of this sequence. What are you going to have? The first 6 term of this sequence, 4k. What are the sequences? What are the sequences now? 4k. The first 6 sequence of this 4k.
I don't understand.
Don't understand. We have
Yes.
done how to use general term or to generate a sequence, Abi.
Yeah.
Now, I'm now telling you, if you want to get a sequence, now this 4k is standing for the general term. Oh yeah, generate the first 6 sequence of this general term, 4k. You don't still understand, Abi?
Size it for.
I said generate sequence, the first 6 sequence of 4k. If 4k is the general term that define a sequence, what is the first system of that sequence?
24.
I'm not asking you for sum. I said generate a sequence. The first 6 sequence. You don't know the difference between, you don't know the meaning of sequence? Okay, let me define it again. If
The first time is 4.
the first time is 4, what is the second time?
The second time is
Yes, 4, 8, 12, 16, 20, 24. Is that not? Is that not? Talk now.
Yes.
Okay, thank you. If you can generate the sequence, then this summation is asking you to what? To add all the sequence, all the what? the system of the sequence. That is what this summation is telling us. And what is it going to give you? If you add 4 plus 6 plus 4 plus 8 plus 12 and so on, what is it going to give you? Let's look at it. It's just going to give us 4 times 1 plus 4 times 2 plus 4 times 3 plus 4 times 4 plus 4 times 5 plus 4 times 6, which is equal to 84. Do you understand it?
84.
Do you understand it? Do we understand it? Now let's do the same thing to the second question.
Yes,
What's the
sir.
second question? How many times are we getting for the second question? How many times? 5. Thank you. From k equals to 1 to 5. Oh yeah, help me to get the sum of the first 5th term of this sequence. Oh yeah, what's the answer? What are the sequences? Oh yeah, the first question. What are the sequences? What are the sequences? Or the sequences?
1 over 2.
1 over
1
2.
over 2.
1 over
1 over
3.
2, 1 over 3, 1 over 4, 1 over 5,
1 over
and 1 over
3.
6.
1 over 4. 1 over 5.
5.
Oh yeah, add them together. What are you going to have? What do you have?
1 over 20.
1 over
1 over 20.
1 over 20. Any other different answer? It's not 1 over 20. It's 29 over 20. You cannot say 1 over. You are going to find the LCM. The LCM is 20. Now, if the LCM is 20, then we are going to combine it. The answer is 29 over 20. Do you
29
understand? The LCM is not even 29. It's not 20 gone. The LCM should not be 20. Let me check it. The LCM is going to be what? 24. It's not 20. It's going to be 24. Is it 24? What's going to be the LCM? What's going to be the LCM? Class, what's going to be the LCM?
3, 4.
What's going to be the LCM of that number? We have 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6. What's the LCM?
50.
30. Thank you. The LCM is 30. Is it 30 or 60? The LCM is 60, not 30. It's 60. Thank you. The LCM is 60. 2 in 60, 30 plus 3 in 60, 20. 20 times 1, 20 plus 4 in 16, 15 plus 5 in 60, 12 plus 10. At the end of the day, I have 30 plus 20, 50 plus 15, 65. 65 plus 22, that is 87 divided by 60. 3 in 87 is 29. 3 in 60 is what? 20. That is why we have the answer to the 29 over 20. Do you understand it? Do you understand it?
Yes, sir.
Okay. And that is where we are going to stop for today. On Wednesday, we are now going to look at forms of sequence. We are going to look at arithmetic sequence, and we are going to look at what? Geometric sequence. But before that day, please try to understand how to generate sequence from general term, and also how to get general term from sequence, and also how to use recursive formula to also generate sequences. And also the last one is how to get series or to add sequences together using what? Series notation. We are going to stop here for today. See you guys. Before I go, any question? Any question?
Not really.
Okay, if there is no question, see you guys on Wednesday.
This video because I didn't hear very well. The connection of my street is very bad. Hello, sir. How can we get this slide to this video? Because the connection of my my God.
Okay, I will send the slide later.